Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back to my channel. In this session we will see if I have any type of electronic board and we don't have its schematic diagram, its circuit diagram, we don't have any service manual, how we can draw its circuit. Drawing a circuit from a furnished PCB, this process is called reverse engineering. How we can make circuit diagram. For that purpose, I will share the easiest way to decode this circuit in any diagram form. There are many processes. Today I will share the easiest way to make circuit diagram from a PCB. Take this PCB to photostat machine. You can make a photocopy. You can scan it and take printout. If you take a color printout, that is much better. Or you can take a picture from mobile camera with some good resolution and take a printout. We have this print side here. Now the same is here. And then we need a carbon paper. Take a blank paper, white sheet. Under this carbon paper, place this picture on the top side of this carbon paper. Take some paper clip and we will hold it here. What we will do, we will start from this end. We will move step by step and we will monitor all the joints, all the connections, what is here, what is there. Let's start. We have input terminals here. We will draw lines from these 2 points at this point. Then this line, it is reaching here. What is here? Here is a fuse. You can see. In the first step, we will make just only the symbols and then we will draw the circuit. We will make a track here. We will trace the line. And we reached here, then this line is terminated and it is passed to this jumper that is here. So we will draw this jumper from this terminal and the second jumper to this point. So it is our jumper. We reached here. From this point, first of all we will make track and then we will place components. It is reaching here. Okay, trace this line from this terminal to here and it is reaching here. Then trace the second line. It is from this component to here. So we will make routing to this component and we will bring it here. Now what is here between these 2 points? This point and this point, we have this capacitor. Place a capacitor here and make nodes. So we will know that here is a connection. Then from this point we reached here. Here we have inductor, a dual line filter at these 2 points because these tracks are terminated here and current have to pass through this inductor. Let's draw this inductor here. Then the current will pass through this inductor and it will reach to this bridge rectifier. From this point to this bridge rectifier. Make track here and make track here. This node, it is here. Here we have bridge rectifier. First of all we will draw as a block. When we will make a finalized layout, then we will draw its detailed symbol. Now this end is negative terminal, it is reaching here. Positive terminal is this side. If we locate here, this terminal is connected to capacitor positive terminal, and this is inner side terminal, that is negative terminal, this one. We will place a capacitor here, so current passed here, and trace this line. What is here? Here is a transformer. So positive voltage reached to the transformer primary winding, and if you look at the same terminal, it is reaching here to the capacitor. This bypass capacitor, class C capacitor, so it is connected to the positive terminal with the bridge rectifier, and here we have this capacitor. Now we will check this point to this point, it is winding. This is primary winding because positive is connected here and the second side is connected to this PWM IC. So we will make a winding here between these 2 points. And this negative terminal that is reaching here at this capacitor, it is reaching to winding this terminal. Now this is grounded terminal, it is bias winding because one end of the primary side, one bias winding is connected to ground, the second terminal is connected to this resistor. So we have winding here. Here we have resistor 6R8. This is SMD resistance. That is this one, 6R8, 6.8 ohm resistance. In the initial condition, we will just only draw the symbols. Then we will make a finalized layout. Then this track is reaching to this diode, SMD diode. We will make diode here. If you cannot see the diode bar side, cathode side, you can identify using multimeter. So this is cathode because negative lead is here, positive is here. The output of this rectifier is reaching here. Here we have Zener diode, ZD102. Zener is always placed in a reverse polarity because Zener works in the reverse polarity. Then this track is reaching here at this terminal, and same point we have one capacitor here, that is bypass capacitor. Then this point is reaching here. Here we don't have anything, and here we have one resistor from ground to this point. That is this resistor immediate closer to this capacitor. Then these voltage are reaching here, and here we have a capacitor, that is VCC capacitor, that is connected in the output of this Zener diode. Now bring this point, it is coming here, it is reaching here, then here, then to the optocoupler, and here we have optocoupler. Make a block for optocoupler. Then this is the output terminal of the optocoupler. It is connected to this point, and here we have what is there. We have a jumper here. We will make a jumper between these 2 points. It is reaching here, and here is a bypass capacitor that is connected to this ground terminal and the output terminal. This is pin number 1. If we see this IC, on this IC we have cut, and here we have index mark, and it is pin number 1, 4, and this is the last pin, pin number 8. And if we check here, This is pin number 1 because it is inside pin. Now this is pin number 8. So opposite to pin number 8, this is pin number 1. We will take just only this sample and it is reaching here. And the same is connected to this capacitor. If we look at this IC, pin number 4, that is connected to this optocoupler, because optocoupler is from this point to jumper, and pin number 4, here we have a capacitor. Let's draw this capacitor here and draw this line here. Pin number 4. Pin number 3, that is connected to ground, and pin number 3 is connected to this capacitor, and the ground is connected to this capacitor, which is connected to pin number 1. C103, we have one capacitor here that is connected to pin number 1, and we have capacitor between pin number 2 and ground. I think primary side connections are completed now. Yes, now we will draw the secondary side. Now if we locate this transformer have 1, 2, 3, 4 pins. These 2 pins are terminated. These don't have any connection. So just only it have these 2 points. Let's check with the multimeter. These 2 points are terminated. Just only we have these 2 points of the winding. Output side we have this diode. So cathode is in this side, and if we check it in opposite direction, it's open. In the secondary winding we have this diode that is here, then we have capacitor here, and we have this winding here, and this is the common pin, ground pin, and this ground pin is reaching in the output terminal. So the ground is reaching also to this component, that is TL431. This is the output of the rectifier, and in the output of rectifier we have this resistor. It is connected to this capacitor. So it is RC snubber for this diode. We have this capacitor. So capacitor negative side is here at this point, and now these positive voltage are reaching here. These positive voltage are reaching here, and we can see this point is connected to this resistor, that is the ground side. Here we have resistor, we have one resistor, second resistor, 2 resistors in series, then we have this capacitor, it is connected between ground, and we have one resistor R204 positive, and it is reaching here. If we look closely, this is our positive terminal. Positive terminal is reaching here, then it is making a voltage divider network at this resistor. This resistor, this point, and with 2 resistors. So this is our reference pin. Here we have reference pin. These are the positive voltage, these are reaching here. We have resistor here at this point, and in parallel we have one capacitor here that is connected together, then we have one resistor here. This is our TL431. This is the reference pin, and this is driving to the cathode of the optocoupler. Cathode, anode. If we see, anode is connected to this resistor, and it is connected to this resistor, and it is connected to positive voltage. So it is current limit resistor. Now approximately we draw all the circuits. Yes, now we have some good idea about the circuit. Now we can redraw it. Now we need a lead pencil and eraser. Now we can make a simplified diagram from this schematic, this layout. This is our input terminal. Place it here. Input terminal. In one line we need to place a fuse. The second line, that is here. Then in the both lines, line and neutral, we have class X capacitor. Then we see the current have to pass from this inductor. So place a dual line filter. Okay, until now we have completed this. Then we will pass to bridge rectifier. Then we have here bridge rectifier. We can draw a symbol AC, positive, negative. This positive and this is our negative terminal. The same here. This is positive terminal, so positive terminal is reaching to transformer winding, which we draw here. It is reaching here and the winding is being driven through this IC. Pin number 5, 6, 7, 8. And if you look at with this capacitor, we have one resistor in series and it is connected to ground. Pin number 1, 1, 2, 3, 4. Pin 3, that is grounded. This is pin 1, 2, 3. 3 is grounded. So we grounded pin number 3. We will make the second winding. This end is grounded of this auxiliary winding, that is here. And in the second side we have one resistor. Then we have a diode, that is this one, and it is providing voltage to this capacitor. These voltage are reaching here and it is provided to a capacitor. This end is grounded because this is our ground line. So this is grounded and these voltage are reaching to pin number 2. Here we have pin number 2 that is reaching to this capacitor. In parallel to this we have a clamp Zener diode. This is 6.8 ohm. We will note down the values after that, no problem. Here we have optocoupler. Optocoupler, this pin is grounded, that is here. Emitter is grounded. Collector is providing voltage, output voltage. Collector is connected to pin number 4 and there is a capacitor in the output of the optocoupler. Okay, make transformer output winding. In the same point, in this output terminal, at this point, transformer this winding end, we have a capacitor here, that is here, and it is connected to pin number 1. And then we have a resistor here, that is here, R104. It is connected between. We have a rectifier here. Now we have this diode here in the winding, and winding one end is grounded, that is secondary ground. This is primary side ground. Okay, we can make it primary side ground, and this is secondary side ground. And in parallel to this rectifier we have a RC snubber, and in the output of this diode we have a capacitor, that is this one. In this output we have this resistor network, one resistor, the second resistor, third resistor. That is one resistor, second resistor, and this end is coming to reference pin. Positive terminal, one resistor. After this resistor, it is reaching to reference pin, that is here. 1, 2 is grounded, and this is reference pin, it is reaching here. And we have one resistor here that is connected to, from this positive terminal we have here, and then we have one resistor that is connected in parallel. This resistor is connected in parallel to anode to cathode. Okay, and pin 2, pin 3 is here. This end is grounded. Capacitor connected to this ground. After these two resistors, we have one capacitor ground. We have this capacitor here, it is grounded here, and this is our output terminal. Now we can place the values of these components. We have one capacitor here between positive and secondary side ground, and we have a capacitor between the ground and low side ground. Now when we will place the values, this circuit is ready now. So this is the idea. In this way we can make a diagram from a PCB. If you enjoyed this video, hit the like button. If you have any question, please let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.